I am Andy Goida. I'm the Canadian Builder Lead, so I work with builders right across Canada, working on very cost-effective solutions to building high-performance homes. With me is Jennifer Weatherstar from Reed Heritage Homes from Cambridge, Ontario, and she is the Director of Innovation and Implementation at Reed Heritage Homes, and she'll be giving a builder's perspective about moving air barriers from inside to outside. We're going to talk about what's happening with the codes. We're going to talk about the benefits of moving that air barrier from inside to outside, the importance of air tightness as we go forward. Without that, nothing happens. It doesn't matter how much insulation you put on the wall, how much continuous insulation you use on the outside of the home. If the home leaks, then it's all for naught. So what we need to do is really determine how we're going to get homes super tight. Right? Because that's where we need to be when we start going to net zero ready. Right? And here's what's happening. This is what's driving it in Canada. Every 3 to 5 years now, we're going to see significant increases in energy efficiency along with air tightness requirements as well. Right? So and this isn't a question of if this is going to happen, it's when it's going to happen. It's going to happen in 2030. We'll be at net zero ready. Right, as a code. The other thing we're doing in Canada is going away from this rating system, because nobody understands, a homeowner doesn't understand what an InterGuide 80 is versus an InterGuide 83. And yet you're paying $5,000 more for a home that has an InterGuide 83. Right? You know, consumers are looking at this and they're saying, well, wait a sec now. When I was in high school, an 80 was an A and an 83 is an A. So, and I'm paying $5,000 more for an 83? Why? They didn't understand that going from an 80 to an 83 means 25% more energy efficiency. That home has 25% or is 25% more energy efficient, right? So the new rating system that I'm going to talk about too is going to show that very clearly. The other thing that's happening is in Canada, there's the R2000 program. That was the pinnacle of energy efficiency in Canada. That's what everything else was based on, high performance homes were based on. What we're finding now is that Energy Star is going to become the stepping stone to net zero ready. Right? So R2000 has outlived its usefulness. Our Energy Star now is stepping in. The next version of Energy Star in Canada, 17.1, that is going to be the stepping stone to net zero ready. Right, so what's going to happen is Energy Star, for those Canadian builders who are not building Energy Star right now, they are seriously looking at doing it because it has become the most successful energy efficiency program in the history of Canadian construction. It has just taken everything over. Plus the Energy Star logo itself, the marketing behind it, I mean, this has 86% brand recognition in the marketplace. So everybody is looking to Energy Star, right? So the other thing that's happening too in Canada, and some of the provinces are leading it further than others, but everybody else is eventually going to come up, is they've developed the STEP code. In Canada, the National Research Council is responsible for the National Building Code. They invested significant time and energy and money to helping the province of BC develop this STEP code, right? So this STEP code now, once you reach step 5 by 2032 in BC, you are building net zero ready homes. The next national code that comes out in Canada will be a STEP code. Right? So already meetings are going on, code committee meetings are going on, where you're going to see STEP codes introduced. Right? And by the way, I think this helps the industry big time because builders now understand what's going to be happening, right? Instead of waiting for the codes to change and then trying to scramble to try and catch up and the rest of it. And that's why the Canadian Home Builders Association has formed the CHBA Net Zero Council, and they're working hand in hand with the government. So this isn't one arm dictating to the other. These are both working together to help drive this and drive it cost effectively. You can build net zero homes. That's not an issue. The issue is affordability. right? You can throw all kinds of money at net zero, but if people can't afford it, then why bother, right? So we're looking for cost-effective solutions on how to do that. And it's not just Canada. Here in the US, they're headed in the same direction, right? Getting down to net zero already as well. And it's not only North America, but it's happening, it's happening right around the world too. In Japan, as of the end of 2014, they had built 20,000 net zero homes. The last number I heard was at the end of 2016, they had 60,000 homes built that are net zero. California, for example, right? All homes built to a net zero standard by 2020. In Europe, all new buildings now are going to be zero energy by 2021. And in the UK, they've gone to a very aggressive grading system from A to G, right? Emphasizing the energy efficiency of the buildings. So it's not just in Canada or America. This is a worldwide process that's going on right now. This is the new InterGuide rating system. This is now taking BTUs and kilowatt hours and combining them into a gigajoule. This now, when a house gets labeled, this is what the homeowner gets. And the homeowner will be able to understand now what a code-built home is and what they're buying and where the energy in that home is being used, right? The other exciting thing about this is it has a file number, and the homeowners can go onto the government site, punch in that file number, and their information comes up, right, in terms of what the energy efficiency of their home. So if they decide to make any changes to it, like upgrade the mechanicals, for example, in the home, they punch that in, and it'll tell the homeowners what the end result will be in terms of energy efficiencies. So that's something that this is going to become the builder's best-selling tool ever. This is going to be terrific. And new homes will be labeled with this, but existing homes were just a stone's throw away from existing homes being labeled as well. Right, so this will be an eye-opener for the homeowners when they look at energy efficiency in the homes. In terms of heading towards net zero ready, what is the most cost-effective way of doing it so that you can maintain the affordability of the home? The first thing is conservation. You conserve the energy that's needed, right, to run the house. So you do that by building a super tight, super insulated home. And now when I say super insulated, I'm not talking about walls that are 4 feet thick. Current construction methods, but tweaked, right? In other words, more R-value in the cavity and continuous insulation on the outside. And sometimes that continuous insulation will get thicker as we go along as well. So conserve first. That is the best bang for the builder's dollar and the homeowner's dollar, because it'll make it more affordable, and then you generate what's needed. When you take a look at why conservation is so important in all of this, code-built home today, 63% of the energy in the home is used for heating, right? When it becomes a net zero ready or net zero home, 13% of the energy is used for heating, right? The biggest load now is the occupancy base load when you head towards when you get into a net zero home, right? But then again, the more you conserve, the less panels you have to put up, which makes it affordable for the homeowners. Okay, so when you're heading towards net zero, this is a no-brainer, right? If you take a look at what's leaking, air leakage and ventilation accounts for 30% of the loss. Walls are 20, windows are 20, basements 25, attic is 5%, right? So when you look at it, what are you going to do first, right? You address the envelope, right? You make a house tighter, better basement, better walls, better windows, and then optimize mechanicals as well, right? When you take a look at air leakage destroys homes. No ifs, ands, or buts. It's not vapor diffusion, it's air leakage that drives moisture into walls. There's 3 air leakage mechanisms: wind, stack, and mechanical effect. The wind is pretty well straightforward. It hits one side of the house, creates a positive pressure. On the other side, there's a negative pressure. So whatever air gets in, that same amount has to exit the house as well. Problem is, what you're losing through air leakage is conditioned air, right? Whereas what's coming in is the contaminated air that you have to refilter and recondition again, right? So air changes. If you're in a home that has 3 or 4 air changes per hour, what that means is you're reconditioning that air 3 or 4 times an hour, right? And that's where the costliness comes in. Stack effect is when cold air comes in through the bottom of the house, that air gets warmed, rises, and then escapes up to the top, and then what you get is you get a convection loop forming here, right? Which takes away from the effectiveness of the insulation in the exterior walls as well. And then mechanical, that's when you've got a really super tight home, but you haven't ventilated it properly, right? So you haven't got mechanical ventilation in house, or your furnaces and hot water heaters are not vented directly outside, right? So you create backdrafts whenever the hood over the fan comes on, somebody turns on a bathroom fan. So you get backdrafts coming, right? Which isn't a good thing anyway. In Canada, for example, stack effect is what really is the real concern. It's 30 to 40% of the heat loss and 20% of the cooling loss, right? And you stop that stack effect by an effective envelope, right? You stop air leakage altogether, right? Here's the other thing, and this is why air leakage destroys homes. For the longest time, it was thought vapor diffusion creates the moisture in the cavity. That's not the case. By the way, the last 2 slides came from the Canadian Home Builders Manual. This study was done in Ottawa at the Canadian Housing Institute. Over a typical Ottawa winter, this is the amount of moisture that got into the wall. Through diffusion, 1/3 of a liter, right? And that's what was thought to have been the culprit for issues with condensation, right? But through air leakage, 30 liters of water in the cavity, right? So it's not vapor diffusion, right? It's air leakage that causes the issues, right? And uncontrolled air leakage, that's what it causes, right? That's why it's so important as we go forward, right? More insulation in the wall, higher R values in the cavity, continuous insulation on the outside. If any moisture gets in, if that house still leaks, this is the kind of stuff you're going to wind up with, right? Because there's no way for that house to dry or those walls to dry out anymore. So you got to prevent them from getting wet to begin with, okay? So air barriers, interior versus exterior. Right now, 90% of the market is in Canada, using 6 mil poly as their air barrier, right? So a lot of detailing to sealing it. Electrical outlets have to be sealed properly. The issues around bathtubs, that's always an issue now in terms of how you seal that vapor or that air barrier behind bathtubs and that kind of thing. So that is going to be history, probably in about the next maybe 5 to 6 years. We have builders now who have moved that air barrier to the outside using our code-board air barrier system, and they're looking now at pulling poly altogether. And now, the codes still call for a vapor retarder. You can't build a home without one, right? But they're going back to a vapor barrier paint or a vapor retarder paint, which is typically the primer, right? And even though that paint is more expensive than what they're currently using, when you take the cost of the cost of the poly and the labor involved in sealing it, you're not going to have any issues with cost, right? So that's what's going. When you move the air barrier to the outside and you use the continuous insulation as the air barrier system, in one application now, you're addressing air leakage. The system is a weather barrier, a moisture barrier, and it addresses thermal bridging, right? All of that in one application, right? And it's certified by a third party. In Canada, CCMC. We have an evaluation number, not only for the foam or for the system, but for the tape that goes along with the system as well. One thing you have to be careful of is there are products out there, ours included, that is an air barrier, right? Our product is an air barrier, but you can't put it on the wall and say, okay, now you've got an air barrier on your wall because you're using our product. It has to be a system right? So that's where the gaskets come in, and that's where the tape comes in. And that's what CCMC has recognized, that this is a system. It's not just a product that's an air barrier, it's a system. Okay? So the benefits of continuous insulation and air sealing from the outside. First off, thermal bridging. This is package A1 in the code, in Ontario, for example. So OSB, R22 and R24 batt in the cavity, right? And this is what you get in terms of thermal bridging, right? You can't build net zero ready or net zero with that, right? You take 1 inch of foam, that same wall system, put 1 inch of foam on it, and this is what you get now, right? So you get a significant reduction in thermal bridging. Right? The other thing with using continuous insulation on the outside is not only does it air seal, right, but it warms the cavity as well and reduces the risk of condensation. The wall on your right, has OSB with an R20 batt in the cavity, and R20 is an R19 when it gets compressed into a 5.5 inch stud, right? 20 degrees outside, minus 20 degrees Celsius outside, plus 20 degrees Celsius inside, right? The back temperature of the back side of that sheathing is minus 18.5 degrees Celsius. Put 1 inch of foam on the outside of that, on R5, and it raises the cavity temperature to minus 11.5, or 11 degrees Celsius, minus 11 degrees Celsius. Significant increase in cavity temperature, which means a significant reduction in condensation in the cavity. This is a graphic form of that. This is a house, 2x6 stud, R20 batt in the cavity with OSB. Right, dew point is 21 degrees Celsius, 35% relative humidity in the house. Right, look at this risk of condensation from November almost to April, to the end of April. That's the kind of risk that's built into that home when it comes to condensation, right? That's what you don't want. Now, take that same wall system and put 1 inch of foam, right? And now your risk is from the end of December, right, to about the beginning of March. So basically what you've gone from is this, and you've cut that risk almost in half in terms of condensation, right? 1.5 inch foam on that same wall system, which is an R7.5 on the outside of the wall, right? And again, significant reduction in the risk of condensation in the cavity. When we get to net zero ready, it's on average, it's going to be 2 inches of foam on the outside, depending on what climate zones you're in Canada, right, or heating degree days. But for the most part, it'll be 2 inch, right? Some of the colder regions will go to 3 inches of foam on the outside, with more R value on the inside. But if you put 2 inches of foam, right, on this wall, there's the risk of condensation. So you do not need poly as a vapor retarder. You don't need it anymore, right? Whatever condensation forms in the cavity now, because the home is so tight, it's going to dry to the inside, or it's going to, the moisture is going to move to the inside, and then the mechanical equipment will take care of the rest, right? So there's no requirement for poly in the homes anymore. You still need a retarder, a vapor retarder, but you can do that with paint and just get rid of the poly and the labor it takes to seal it. Okay? So the cold board air barrier system is basically 3 products. It's our foam, it's our sill gasket, and it's our tape. Right? And it's been and it has been certified by CCMC as a system, right? And we are bringing builders in. We're bringing builders in at 1.5 air changes at the framing stage, and we do blower door tests at the framing stage. So, and we'll bring the framing crews in. We'll bring the building officials in when we do the blower door tests at the framing stage, so the building officials can see for themselves how effective that is. And that eases their minds when you start pulling poly out as well, right? So we invite building officials in. We have the framers in there as well so they can see. And we have the site supers in as well so they can actually see the results for themselves. In terms of fastening, I mean, the equipment is out there to fasten foam to the stud walls, with nails, with washers, right? There's guns that'll marry the two and fire them through, so that's not an issue. Right? Now, I'm going to show you a video. This is available on our builder site.
This first floor sequence shows a typical installation of the OwensCorning code board exterior air barrier system with and without OSB, with brick cladding. Install a layer of OwensCorning 3.5-inch foam sealar compressible ceiling gasket beneath the 2x4 sill plate anchored to top of concrete foundation wall. Build first floor platform. Staple a layer of OwensCorning 3.5-inch foam sealar compressible ceiling gasket along the perimeter of the rim joist. Build first floor wall structure. Staple a layer of 3.5-inch foam sealar compressible ceiling gasket around all window and door openings. For a 9-foot foam board application, install 4x9-foot foamular code board insulating sheathing boards vertically over wall framing and attach to framing using appropriate nails with washers. Tape all joints using OwensCorning joint sealar tape approved for use over foamular code board XPS foam sheathing. Taping the shipped lap joints is optional, but will improve the overall air-tightness performance. Lift wall into place. Complete nailing along rim joist to ensure proper compression of ceiling gasket, and tape corner joints of all walls. Add a bead of caulking sealant along top of foundation wall and install flashing. Tape the top of flashing to the foam board using flash sealar tape. When using OSB as an intermediate sheathing layer, install compressible ceiling gasket around all window and door openings and at the bottom of the rim joist. Install OSB and then install a second layer of compressible ceiling gasket around all window and door openings and at the bottom of the rim joist over the OSB. Install code board insulation, tape all joints, caulk the top of the rim joist, and install flashing as per the 9-foot application. For an 8-foot wall application, install compressible ceiling gasket around all window and door openings and at the bottom of the rim joist. Install 4x8-foot foamular code board insulating sheathing boards vertically over wall framing. Tape all joints. Install foam header insert and nail the horizontal joints in the foam board. Tape all joints and corners using joint sealar tape. Install flashing as per the 9-foot application. Install brick ties and masonry to finish walls. Install EcoTouch pink fiberglass bat insulation and vapor barrier on the inside of the wall assembly.
All right, so here are some of the more important details of the system. It's really basically easy. You can apply it with or without OSB. The videos are on our builder web page, so you can download those videos. You can use them for training internally. And there's various videos. There's about 6 or 7 videos that cover pretty well everything that needs, actually everything that needs to do with installing the code board air barrier system. The continuity, and we get building officials asking about this, and builders asking too, is, well, okay, so I installed this, where's the continuity of the air barrier as we go through, right? You're telling me to remove poly, but I still have to use poly on the ceiling, right? And that's right, you do, because that is your air barrier. So where's the continuity in that respect? Well, it's from the foam to the sill gasket, to the top plate, to the caulking, to the poly, right? So that's the continuity, right, at the top of the wall. So it's really not all that difficult. This can be used with brick, can be used with siding, you can use this with stucco, you can use it with brick and siding, right? So the system is not all that difficult to install. Typically for a framing contractor, it's one house. The learning curve is one house for a builder, because it doesn't change anything in the process. You're not changing the construction process, it's not taking longer to frame the home, right? So instead of using OSB, you're using a foam sheathing, and you're gasketing that foam sheathing to make it the air barrier, okay? We've also have, in terms of fastening vinyl siding or any kind of siding other than brick through the foam, there's certain nailing patterns you have to use. All of that has been captured in this report, and we have developed technical bulletins for cladding that goes right over top of the foam and for cladding that goes over furring strips as well, right? So all of that is in a technical bulletin that we have that's included in our code air barrier system package, right? The other thing is windows and flashing windows properly. I'm telling you, I love the way Gord Cook puts it. Gord Cook is from Building Knowledge in Canada, and he's owner or part owner of Construction Instruction in the U.S. And I love the way he phrases this. There are two types of windows: windows that leak and windows that will leak. And it's not because of deficiencies in the manufacturing of the window. It's that when new homes are built, they move and they settle, right? And that settlement is what causes the leaks, right? So you have to ensure that if water gets in, that it has a chance to drain out, because if it sits there, it's going to cause all kinds of issues.
This video shows a box-to-window installation incorporating a complete air and moisture management system. Install a sloped sill or a dam and seal the four edges of the rough window opening with strips of OwensCorning Canada's Flash Sealar tape. Protect bottom sill using Flash Sealar flashing tape with minimum overlaps. Install box-to-window into the rough opening. Tape the two vertical edges of the window to the foam using Flash Sealar tape. Then tape the top horizontal edge of the window to the foam using Flash Sealar tape. Do not tape the bottom horizontal edge of the window in order to maintain the drainage gap. Install metal head flashing with end dams above window and seal to the foamular using Flash Sealar tape. Seal the gap between the window and the rough opening on the interior side of the window using an air sealing material for air barrier continuity.
Okay, and again, there's a video on flanged window, flashing flanged windows as well. So our tape, we have a seam tape and we have flashing tape. Both have CCMC evaluation numbers for them as well. So they're part of that whole system. One of the reasons we developed the tape was that we weren't confident that the current tapes in the marketplace would last for the life of the home. This is a vapor barrier, and an air barrier system, and we're telling builders that you're going to have an air barrier system in place for the life of the home, right? So we needed a tape that we could trust in. There's too many times I've been by sites and I've seen tape being applied, and then the temperature drops, and you come back the next day and you see that tape flapping in the wind because it's let go, right? So that can't happen with this. This is very, very aggressive tape. Right? And the first time the framing contractors use this, they will be cursing like there's no tomorrow. But once they use it, and once they know how to use it properly, right? And it takes them one house to learn very quickly, because you make a mistake with this tape, you're not pulling it off. You try and pull it off, you're pulling off a layer of foam with it. That's how aggressive this tape is. Plus, it's very, very stretchy tape as well, so when the house settles, the tape moves with the house and it doesn't pull away from the foam. The other result for the copeboard air barrier system too is using it in garage ceilings that have rooms above, right? For the most part now, everybody is spraying, and the cost of that spray foam is typically around $1,200 a house, $1,200 a ceiling, right? You can do that for literally half the price, because now you're taking what you do is you drop the ceiling, right? Insulate it with bats. Right, and then take the copeboard air barrier system, turn it this way, and put it up. And that seals everything. So now you don't have any of this, right, where the cold can still migrate through and cause complaints of cold floors over garages and that kind of thing. So This actually seals it and insulates it, so you don't get any more complaints from cold floors, right? The other thing too is that when you're using the cold board air barrier system, any walls in the garage that separate conditioned space, you apply the cold board air barrier system to that as well. Okay, so sometimes there's only one wall, sometimes there's two walls in a garage that separate conditioned space. Oh, okay. Right, so on the Builder website, when you go to our website, the videos that I just talked about are all listed here. If you click on the Panther, there are more videos there as well that talk about the building science behind moving air barriers from inside to outside. There's also a manual in place, but we've taken this manual and we've significantly made it smaller. And the reason for that is when we first developed this, we set up a committee for this, and we asked building officials to sit on it and builders to sit on it. And I'll tell you, some of those meetings were pretty interesting. But this installation manual is about 80 pages because the building officials and the builders wanted everything that could possibly do with the system in there, right? So it's a great manual to have in-house for your people to understand it. But for the trades, what we did, and for the building officials as well, what we did was we took that and we condensed it into this. And this has drawings, right, with the footnotes, and then it takes out the key areas and breaks it out, right, and explains on how to install it properly, right? When a framing contractor gets this, they take a look at it and they say, man, what am I getting myself into? When they get this, they take a look at it and they say, yeah, we could do this, right? Because it's very simple, very easy to understand, okay? The other aspect of this is when you start looking at the cost of all of this and making homes very cost affordable, you're not going to be building homes cheaper. If anything, they're going to cost you more to build as we head towards net zero ready, right? But how do you minimize those costs, right? And you do that by taking a look at what moving that air barrier to the exterior and using our system and what it can do for you. So you've got continuous heat, air, and moisture on the exterior of the building, all in one application, and it's an air barrier or a weather barrier as well. It's easy to maintain the continuity of the system, right? Because it's all applied on the outside, so there isn't any issues. By the way, when you use poly, and we had a builder, actually we worked with Reeds on this too. When you're sealing poly in a home as the air barrier, there's typically 45 areas or junctions, right, that you have to worry about. You have to make sure that the poly, anything that penetrates the poly is sealed properly and all the rest of that stuff. So it's not just a simple thing of pulling poly up and sealing it, right? When you move that air barrier to the outside, there's half of those things you have to worry about. So there's only 22 areas that you have to keep track of. So it's very, very easy to do in that respect. Right? Significantly reduces the risk of condensation in the walls because when you put foam, continuous insulation on the outside, you're increasing the temperature of the cavity and you're reducing the air leakage as well. Right? And the cost-effective solutions. And this is where builders really, really need to understand your cost. You can't get a quote now and says, okay, it's going to cost $1,200 a house and I'm going to install insulation, poly, and drywall. That just doesn't cut it anymore. You need that $1,200 broken down, right? Because these are the type of costs you can pull out. You can eliminate weather barriers altogether. You know the house wrap that goes around? What's it cost, typically, material and labor on a house? It ranges anywhere from $900 to $1,200, right? So take $1,000 as the midpoint of that. That's $1,000 a home you can now pull out to do that. Wrapping headers. Right, if you're a builder, do you know how much it costs you to wrap a header? It's all in one cost. We learned, working through Reeds and working through other builders, that the cost of wrapping a header is about $100. So you got two headers, there's another $200. Poly, sealing poly as a vapor barrier, what do you think that is? Right, you're looking at anywhere from $250 to $300 to seal the poly. right? That's just material and labor to seal the poly, not the cost, even though the poly cost isn't very expensive, but still you're saving those dollars for, and not having to do that, right? Airtight electrical boxes, you can eliminate those. Now, you know what, I mean, that's like $60 a house, but still, $60 a house, and you build how many homes a year, right? So $1,000 on house wrap, $200 on wrapping headers, you're eliminating the airtight electrical boxes because you don't need them anymore because the air barrier is on the outside of the wall, right? So you don't need that. The taping and caulking of the poly and all the rest of it. So you now start pulling costs out, and is it still going to cost you to build? Yeah, it is, but it's not going to cost you as much as it did if you were doing it the way you're doing it now, by using the air barrier on the inside, using house wrap and all the rest of the stuff. So it becomes very, very cost effective in that regards. So we have builders now who are talking to municipalities, and we've been part of those discussions, where they're convincing municipalities now to pull poly out. We don't need it anymore. We're just going to go back to a regular vapor barrier retarder, right, and get poly out of there altogether, right? And again, the system and the tape are CCMC approved, and when building officials see that, they don't have an issue with it at all, right? And we have a dedicated website for builders that have the videos, that has the brochures, and that has the manual, right, that you can use for internal purposes as well. So now I want to introduce Jennifer Weatherstar from Reed Heritage Homes. And again, Jennifer is the Director of Innovation and Implementation at Reed's Heritage Homes, and she's going to talk about her experience with the air barrier system.
Hello, everybody. Part of our program is we worked with OwensCorning Canada and EnterCan to build 5 net zero homes. So net zero homes are not something new anywhere, but what was different for us was the fact that we were looking at implementing it in a production setting. So how do we make it affordable? How do we make it implementable and easy for our team members and our home buyers as well? We built 5 net zero homes in that program in Guelph, Ontario. The average co-built home uses 110 gigajoules of energy. We have these down to 37. On the flip side, these were 30-foot lots, which had their own challenges in themselves because you have limited roof space, which becomes your most expensive real estate area. This past December, we opened up a 3,200 square foot model home with a 0.06 air change, or 0.6 air changes. As well, it uses 46 gigajoules of energy, which is pretty phenomenal for a 3,200 square foot house. So kind of like what Andy talked about earlier, a lot of the loads in your home are reduced by about 67%. Your largest load in the house was your mechanical systems, and now it's your occupant load. So it's about teaching people how to live in their homes as opposed to leaving flat screen TVs on and whatnot. It's about being a little bit more attentive to where you're leaving phantom loads running at other times, because your house is not your predominant load of energy anymore. In fact, on your utility bills, you're probably going to pay more in delivery than actual consumption. We also use gas. In Ontario, natural gas is a very affordable option, so we have basically hybrid systems. Our first home was a fully electric home, and the second home and every home thereafter is a hybrid system with an air source electric heat pump combined with a natural gas backup furnace so that it will shift at a set temperature point when it becomes more affordable for the homeowner to change fuel sources. With a 30-foot house, the first house we did a covered porch. It was beautiful. It was about $100,000 and not affordable. So what we learned on these houses was if we push the ridge line forward, drop the slope of the roof, you can fit all the panels on the back of the home and therefore net the house out with the loads. What you find as you go through developing your homes is you start trading equipment. So one piece of equipment might be more money, but it's going to save you a couple panels down the road. And if you don't have that roof space, then you're going to start trading those pieces off. Getting to the code board system is a no-brainer. Moving it to the outside, we've worked with municipalities to take the poly off. One area where I will kind of throw that out there that you want to watch is your basements going forward. Because the house is so airtight and you've insulated it, You're going to have the concrete drying to the inside, and you're actually going to have some issues. So you're going to need a breathable poly in the basement, but work with your officials to take the poly out on the main floor. The other part is what you're going to watch is the unknown costs, which is your site labor chasing the hole in the home to find where the air leakage is. We generally do our blower door testing at the framing stage just to head it off, because you can't fix anything at the drywall stage when you start blower door testing. These are some of the comments that we've had. Generally, when we go into any new exercise, we bring all of our trade groups in. So we sit and talk with our framers, our contractors and whatnot, just to find out these are people who are on the tools and know the best practices. We can tell them what we want to do, but we engage them and get their insight. Our first discovery home took about 3 weeks to frame. After that, 10 days, not even. It was much quicker when we changed this wall assembly. We looked at the different types of walls that you could do to be able to achieve the insulation values that we were looking at. And we found a system like a 2x6 wall with an R24 batt and the R10 on the outside was the best system for us. It offered affordability, and it offered ease in production to get our team in and not have an impact on the overall build cycle. So it was a tremendous change. Everybody fights when you change the envelope and you implement something different, but by engaging them and giving them training and having them be a part of the system overall, they found the benefits to themselves, and it actually gave them an opportunity when they were bidding work with other builders, because now they had a skill set that their competition didn't have. The devil is definitely in the details. As the homes get tighter, as Andy mentioned, flashing around the windows is probably one of the most important areas, because the walls are not going to dry out as quickly as they used to. So that's one area where you want to pay special attention to. And unintended consequences, that's Andy Oetting's famous term. Everything has a kind of like a secondary happening to what you choose to do. So when you make it tighter, you have to ventilate. When you make it tighter, you have to watch your flashing and making sure the house is drying out. So we work from a conservation first methodology. So really the envelope is the most critical, getting it to where it needs to be. And from there, everything else is downsized. So as an offset of that, the loads in your home are significantly less. That will not make it more cost effective for you. There's not a lot of mechanical equipment out there that is actually sized small enough to meet the low loads of these homes. We've got townhouses that are coming in at about 10 to 15,000 BTU, and there is only one manufacturer that I know of that can actually meet those loads and improve the quality for the homeowners. What else can I tell you? That is one house that we built for a homeowner. That one as well is in about 46 gigajoules. So it's definitely possible. It's not rocket scientists. We started as a code built, and we brought InterGuide in about the early 2000s, and shifting from InterGuide to net zero already is extremely simple. It's not like LEED programs or certification or anything like that. It's really just about improving the details and how you build. Net zero can come down to 5 simple steps. It's your air barrier system, so moving it to the outside and insulating the house, addressing the right size mechanicals, electrical, so your hot water, your LED lighting, your appliances, your solar system being the last, and then triple glazed windows are the other one. So it's a systematic approach that will get you there.
Okay. Thanks, Jen. Just a couple of comments on what Jen said. Blower door test at the framing stage. If you want to see subtrades take ownership of an issue, when we do the blower door test at the framing stage and we can't depressurize the house because it's leaking somewhere, the framing contractors, it's incredible what they did. They're running around the house trying to find out where the heck it's leaking because they believe they did it right? And once they find it, guess what? On the next house, it isn't an issue. Your framing contractors will take ownership of that whole issue, right? The other thing that Jen was saying was I think you mentioned the comfort of the home and that type of thing. We had a net zero ready home built. So I wish I could package this somehow because it would be the best selling tool ever. My wife in this home couldn't understand why we were spending the money when it was first being built until we moved in. Now she is afraid that if we ever have to move, that we'll never get the same type of house again, that comfort level of hers. She has become the builder's best salesperson. So how do you take that experience and how do you package that and sell it through? Right? And we were talking earlier about doing exactly that with your marketing people, right? Is selling through the benefits of Net Zero Ready, right? So you can sell it, right? People will understand it if you market it properly, and that's what Reed's Heritage Homes has done with their system too, right? So, questions? Thank you for coming and thank you for attending.